So again, we had this homework right here. And that would be part one, and hopefully it went okay. So again, just to reiterate, we will be doing 13-1 all week, and then 13-2 next week, and a quiz the week following, a Friday away. Is everybody good? All right, this should be some review also for you, and that is your special right triangles, okay? Your special right triangles. The 30, 60, 90. And it is good to add an x here, so this is 2x. This is just x, and that's x square roots of 3. If you remember those special ratios, across from the 30 is always x. Across from the 60 is x square roots of 3, and the hypotenuse is always 2x. On the 45, each leg is x, and the hypotenuse is x square roots of 2. Now, they're solving for when the hypotenuse is 1 there, but that's okay. Or in that case, when the hypotenuse is 2 and the 30, 60. But basically, we're going to be solving these triangles. Euclidean called these the most beautiful shapes you ever saw because they're special. What makes them special is that you just need one side to be able to get all the other sides if you know the angles are 30, 60, 90, and the 45, 45. You should have had this in geometry, did you? Do you remember vaguely working with these in geometry? I hope so. We'll run through a few of these here in a second. And then we're going to do a couple of application problems. You're going to need your calculator out for those. So, and make sure it's in degree mode also when you have that calculator out there. So the 3060s are kind of fun. Once you pick up the hang of it, I'll try to give you a couple hints on how to do these. As we move forward, so. How we feeling there? Is everybody good? Note taker still second? All right, you so just a second. And then we'll move forward with that. The puppy's doing well. If anybody's interested. So sleeping through the night. Well, I had to get up at good for about 4.5 hours, and she gotta go out. All right. Let's take a look at this guy right here. Now, I got him a little bit tilted there, but the first step for this is to recognize what this is. It is a 30, 60, 90, isn't it? This is the 30, so that means this would be the 60 and here's the 90. Okay, now if you remember this from geometry, or the first thing I would suggest doing is figuring out if it's a 30, 60 or 45. This is 30, 60. The next thing I would suggest is writing the ratios. The hypotenuse is always 2x, right? The short side is always x. The long side is always x square roots of 3. That's always the case. So if it's a 30, 60, I'm going to put those ratios up. Is that clear, everybody? Now, every one of these, all we really need to do every time is solve for x. Now, sometimes it's much easier to solve for x, and other times it's a little trickier, depending on which side you have. So I'm going to take the ratio that I have to the side that I have. Well, what is the side that I have is what? The only side I have is 74, isn't it? And that's equal to 2x. Does that make sense to everybody? Okay. Well, how am I going to solve for x? Of course, I'll divide by 2. If you need your calculator, grab it. 74 divided by 2 is 37. So, folks, I've solved for my x, and that's great. But what does that mean? Well, that means I'm going to plug that back into wherever x might be. So if this is 74, this bottom leg is just x, which is 37. And this long leg here is 37 square roots of 3. And we're done. So two of the sides are very easy to do, aren't they? Which two? Well, this one's really easy, isn't it? If I say this is 10, if I say this is 10, do you know what this hypotenuse is? It's already solved. This is x. X is 10. I don't have to do any work. So what would the hypotenuse be? 2 times 10 or 20. And this leg would be 10 square roots of 3. It's that simple, isn't it? So the two easy sides are the 2x and the x. The hard one sometimes here because we have to rationalize. Is that clear? All right, so let's try one of those. Okay, here's my 30, here's my 60, my 90. Let's say this side here is 9. Okay, so what did I say? Step 1, recognize what it is, a 30, 60. Step 2, put my ratios in. This is 2x. Across from the 30 is x, and this is x, square roots of 3. So now I gotta solve for x. So x, square roots of 3, equals 9. I gotta figure out what x is so I can plug it back in. What's my first step then? I'm going to divide by square root of 3. And I gotta get x by itself. I'm gonna divide by the square root of 3. So I'm down to x is equal to 9 over the square root of 3. And here's that silly math thing that we rationalize. So let's rationalize. So we'll multiply both top and bottom by square root of 3. So now we have 9 square roots of 3 over 3. We're hanging in there, everybody? Well, of course, 9 and 3 can reduce, can it? Without any decimal or fraction. It can reduce pretty easily. We reduce it to 3 square roots of 3. Well, what does that mean? That well, we've solved for x, and it's 3 square roots of 3. Well, that's good. Now I'm going to go back and look at my, I've got 9 here. Well, this is just x, so this is going to be 3 square roots of 3. If that's 9, this is 3 square roots of 3. This is going to be careful here, it's just 2 times the 3, so this is going to be 6 square roots of 3. So there's your 30, 60, 90. The hypotenuse is just 2x. The short leg is x, and the long leg is x squared root of 3. Remember from geometry a little bit? Everybody okay? Let's try one more. Okay, another 30, 60. I'll make it nice and simple though for you. We'll make this side 24. Should take you about 15 seconds, honest, it should. This side is what? 2x. This side is x, this side is x square roots of 3. What do we gotta solve for? X. What is x equal to, anyone? It's 12, so I just gotta fill it in now. This is gonna be side is 12, this side is 12 square roots of 3. Everybody okay? Let's try one more of a 30, 60. We'll give you a hard side. This is the 30. This is the 60. We'll make this side right here 15. Okay, so step 1, let's label our ratios. 2x, x square roots of 3. So this is what I gotta work on. X square roots of 3 equals 15. So you're going to need to simplify that, get what x is equal to. And you'll see it's the same. You're going to divide by the square root of 3, then you're going to multiply top and bottom and simplify. It is the same process. So if you get the long leg, You gotta do a little bit more work than the short leg or the hypotenuse, but it isn't that much difficult. Square root of 3. Then you need to rationalize. You end up with x equaling 15 square roots of 3 over 3. But there again, 15 and 3 will simplify. So your x is really 5 square roots of 3. So we ended up with 15 here. So this is 5 square roots of 3 because that's x. Be careful here again. This is going to be just 2 times that 5, 10 square roots of 3. Don't take 2 times the radical part. Everybody okay? Let's move on to the 45. Okay? If I have a 45, this is yes. Now I like the 45 because it seems a bit simpler. Your ratios are x, x, x square roots of 2. Of course, I give you the hardest one first there, didn't I? You're going to do the exact same thing you did with the 30/60. You're going to take x square roots of 2, the ratio, and set it equal to the length I have, which is 20. Now, instead of dividing by the square root of 3, we need to divide by the square root of 2 and simplify. Okay? So divide by the square root of 2. X is going to be 20 over the square root of 2. Rationalize. We're going to get 20 square roots of 2 over 2, and we're going to end up with 10 square roots of 2. That is what your x is equal to. So this is 20. This will be 10 square roots of 2. This side will be 10 square roots of 2. Now it's really great when I just give you this. If this was 15, if that leg's 15, what's this leg? 15, and what's this going to be? 15 square roots of 2. It's already solved. X is a, Everybody okay here on the special rights? Should be reviewed from geometry. All right, let's throw a little bit of where we're going to need our calculator now. And we got to figure out which trig value. A water skiing competition, the jump ramp has the measurement shown to the nearest foot. What is the height? H above the water, the skier leaves. So first of all, we got to figure out what we got going on here. We're going to have to figure this height, right? And this is my theta. So this would be the opposite. This would be the hypotenuse, isn't it? You with me? So on these application problems, every time I'm going to draw a triangle. Every time I need to. Now, if you remember which trig function, sine, cosine, or tangent, that's the only one we'll probably use, sine, cosine, or tangent on application problems. Which one is opposite over hypotenuse? Opposite over hypotenuse. What is it? The sine. Okay? So now we're ready to write our little equation. The sine of what angle we have, 15.1, is equal to the opposite, which we don't have, over the hypotenuse. There's your equation. Now here's where you need your calculator again. You need your calculator 2 times. If I'm finding an angle, or if I'm finding a side with a given angle. So grab your calculator. We're going to solve for x. Make sure you're in degree mode. We're going to multiply by 19 on both sides. So really, you're going to take 19 times the sine of 15.1. I am assuming, and it says, does it say to round to the nearest foot? If I recall, I think it's somewhere around 5. You getting around 5? 4 point something, 4.9, round up. So it would be 5 feet. How are we doing? Does that make perfectly good sense? you did some of these in geometry also, didn't you? Okay, you did some of these application problems. Skateboard ramp will have a height of 12 inches, and the angle between the ramp and the ground will be 17. To the nearest inch, what will be the length of the ramp? So we are going to try to calculate this length right here of the ramp. Okay, we have this angle, again, label, opposite, hypotenuse. Well, it turns out to be the same trig body, doesn't it? But we are solving a different spot. So we're looking for the sine of 17 is equal to, this time we have the opposite. We're looking for the hypotenuse. Now this creates just a little different problem because the x is in the denominator here. Does everybody see? So we got to do just a smidge work on it. Okay? We'll multiply by x both sides, then divide by sine of 17. So really your answer ends up being x is equal to 12 divided by the sine of 17 degrees. And you can throw that in your calculator, and it should turn out pretty quickly. Now, make sure it makes sense. If it comes out, 2 inches, 2, you're probably wrong, because look, this is already 12, right? 2, 4, 6, 8, somebody generate? Twelve divided by the sine of 17?
41.
That is correct. So that would be 41 inches. And that makes logical sense if you think about it. 17 degree, 41, it makes logical sense. So now we're starting to get to use our calculator. When do we need our calculator? If we're finding an angle, or we have an angle on one side and we're trying to find the other side. That's the only time we need our calculator. One little definition that you need to remember is angle of depression and angle of elevation. They are the same. So don't get too whacked up about it. It says angle of depression, angle of elevation. They are the same. They are congruent angles. Parallel lines cut by transversal, those will be the same. So that can come up in the word problems. They say angle of elevation or depression. Okay? I am done with you. Thank you. A couple of problems to work through there. You guys are awesome today. Enjoy the rest of the day, and